Today we're going to talk about lesson 36 and we're going to talk about the discriminant of our quadratic formula. So let's write down our quadratic formula first of all. It is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we've talked about negative b over 2a when we talk about axis of symmetry. But today we're going to talk about the discriminant. So your main vocabulary word for this video, one of them is the discriminant. And the discriminant is going to be what is underneath the square root, and that is b squared minus 4ac. And this is when we're talking about a quadratic that is in the form y is equal to ax squared plus bx plus c. So we've been dealing with this equation for our entire year, and now we're going to talk about a really special part of the quadratic formula called the discriminant. And one of the reasons that you haven't noticed that's been going on is almost all the quadratics we give you have real solutions, which means previously when you would take the quadratic and you would find the solution using the quadratic formula, you would come up with a real solution. Except sometimes when there weren't a real solution, we just said there was no real solution, but we didn't talk about that anymore. And today we're going to use the discriminant, and you are actually going to be able to say how many solutions there are. So more vocab to keep track of. We're going to talk about solutions. Some are real solutions, some are real, some are imaginary. Write your vocabulary down. Discriminant. I'm not spelling it very well. I ran out of room. And then I will add more on here. Oh, we use the word quadratic. And sometimes when I say the word graph, I'll use the word parabola, which also means a quadratic. This is the shape of the graph. It's a parabola. Okay, so let's talk more about this discriminant. There's three scenarios. We either have when b squared minus 4ac is greater than 0. And this has happened almost every case. B squared minus 4ac has been greater than 0, and we've been able to find real roots. Then we also have what happens when b squared minus 4ac is equal to 0, which happens, and then you don't end up using the quadratic formula. And then we have b squared minus 4ac is less than 0. So other words for this is when the discriminant is negative. So that's one way you can describe when the discriminant is less than 0. You can say the discriminant is negative. This is when it's equal to 0. And this is when the discriminant is positive. Now, what does this mean when the discriminant is positive, equal to 0, and negative? Well, when the discriminant is positive, let's take a look at the graph. If I had to graph this, if the discriminant is positive, you would have two real solutions, and they would be on the x-axis. So, number of solutions. This is where you can pause the video because we're about to make a t-chart. So we're making a table right now. Once you figure out what the table looks like, go ahead and pause this to make the table in your own notes. Number of solutions. And I'm just going to write this really big. Two solutions. All right. When we have the discriminant equal to 0, we have exactly one solution. One solution. When the discriminant is equal to 0, we're going to have exactly one solution. This is what it looks like on a graph, and this is the word 1 written out very big. Okay, now when we have, you can predict now, what would our graph look like if it had no real solutions? And our graph would either be up here, well, that'll work, or maybe it would look like this. It would be concave down, but it would never touch the x-axis. So this would be no real solutions. But because we're clever, we came up with a way to describe what happens if a root is not real. And we came up with this lovely term I. And it's a unit that we're going to call imaginary. And I'm going to show you what it looks like when we see them in our math. But this graph, definitely, this table, definitely go in your notes right now. Pause the video, copy it down, annotate the words I said onto your paper. Then we're going to move on to an example. So we're going to find the solutions to the graph x squared plus 4. Remember, the solutions are where the graph touches the x-axis. So let's use our discriminant, b squared minus 4ac, and let's see how many solutions it has. Well, I'm going to rewrite this as 1x squared plus 0x plus 4. That way I can see where my a value is, my b value, and my c value. Okay. B squared minus 4ac is going to be equal to 0 squared minus 4 times 1 times 4. And I'm going to get negative 16. Oh, okay. So I go back and I look at my graph. If I have a negative number like this, b squared minus 4ac is less than 0, there's going to be no real solutions. All right, so no real solutions. However, we can still solve for an imaginary value of x using this unit defined as I. So in your notes, this is where it goes. The imaginary unit is defined by I is equal to negative 1. Every time you see a negative 1, that's going to equal I. And bonus, we can even square I. And we can square negative 1. If we square the square root of negative 1, we're going to get negative 1, and that's going to equal to I squared. We're actually going to continue this conversation in a later video, but also an imaginary number is a number whose square is negative. This is what it looks like in math words. I'll just get rid of this part right here. And then this is what it looks like in words. So get those down in your notes. Let's go back to solving this problem with y is equal to x squared plus 4. In order to solve for the solutions, we try to look for where the graph is when y is equal to 0, or when it hits the x-axis. So let's set y equal to 0. We have x squared plus 4. Let's solve for x. Minus 4 minus 4. I get negative 4 is equal to x squared. Now, I'm going to zoom in a little bit. I think I can zoom in. All right. X squared. And now I'm going to undo this x squared by square rooting it. I'm going to undo this x squared by square rooting the right-hand side. Okay, write that down in your notes if you have trouble saying that out loud. Now, I'm going to take a look at this negative 4. And the square root of negative 4 can also be broken up into 4 times negative 1, right? So watch how I break this up using my good radical skills. Negative 4 times the square root of negative 1 is equal to x. Good thing we just learned what I is, because the square root of negative 1 is equal to I. So this is going to turn into I. And then the square root of 4 we know is 2. Oh, I forgot. Once you take the square root, this is going to be plus and minus, because there's a positive. If we're solving for x, we don't know if it's going to be positive or negative, so we have to include both the positive and negative version if we're solving for x, not if we're simplifying. All right, plus or minus. So x is either plus 2i or negative 2i. And that may look really strange, but 2i is what we call a pure imaginary number, and it's always written as bi. So that's one way we're going to refer to it. I'll ask you, like, what is the b value? Because b is going to be a real number. It's going to be 1, -5, 3, It's going to be 3/2. It's going to be the square root of 3. It's just a real number. It can be rational. It can even be irrational. It's just got to be a real number. Now, next to it is going to be I. So that's what a pure imaginary number is going to be. In this case, our pure imaginary number was 2I, both positive 2I, and we had a negative 2I. Okay, but sometimes we have these things called complex numbers. Let's scroll down. A complex number is any number that can be written in the standard form A plus BI. A and B are going to be real numbers. Like I said, that means real numbers. As you pause this video so you can write down this definition, you can also put down under real numbers and annotate that these include fractions, rational numbers, fractions, decimals, irrational numbers, integers, even 0. These are all included in real numbers. Those can be A and B, and then I is going to be your imaginary unit. So in another table, we have a complex number in standard form A plus BI. A, in this case, in this example, I'll say example 1, we have 7 plus 2I. So our A value is 7, and then our imaginary part is 2I, positive 2I. And then same for this A value is going to be 1, and then our imaginary part of this complex number is going to be negative 5I. And then our A value here is going to be 0 because there's no part that's just a real number. But our imaginary component is going to be 8I. And now we have a fraction here. And I'm going to zoom in a little bit. So we have a fraction and we have a common denominator. And having a common denominator is really good because we can split it up into 2 fractions again. We can do negative 2 and 5 plus 3I and 5. So now we have our real number component and we have our imaginary number component. So our A value is going to be negative 2/5. And then our imaginary component is going to be 3/5I. Make sure you include your summary here. There was a lot going on, so go back and rewatch and then summarize and annotate and then bring your questions to class for tomorrow. Bye.